Okay, time for time. I've been working on the philosophy of time for about 20 years. And it's probably one of the most difficult areas and subjects. I don't know really how much farther. Okay, I've made a little progress within 20 years of thinking. But that's 20 years, so I don't expect we're going to solve the problems of time in a 2.5-hour class. So you know what we'll do? We'll do a sort of compromise. Let's have a buffet style of all the various thinkers, and I'll divide some of the greats. And what I'll do is I'll divide those into two camps. Philosophers and the way that they think and treat time, and then the physicists, so kind of from the scientific perspective. And I want you to think as we go through here in the lecture, what do you think how do they treat the issue of time differently? How do the philosophers think about time, and how do the scientists, the physicists, talk about time? Time is kind of paradoxical. If you think about it, it's the closest thing to you. Your whole day, your whole life is structured by time. Your thoughts, in fact, even your identity. I had an episode, I was a senior in undergraduate, and I went surfing, and I knocked my head, and I got amnesia. I forgot everything. And it's slowly, these memories started kind of popping up, but they were not connected. They were just, it was like somebody shook up and then all the stuff just started floating up. I didn't know where I was, nothing looked familiar. And then I started to get memories, and there were memories not just of events, but intentions to do things as well. So you might have had this episode too where are my books or keys? I know that I brought them into the house with me. Or did I? Am I just remembering that I had an intention to bring? How many have had that? Or the last time. This is like the story of my life. My wife gets so frustrated with me. She's like, why can't you remember? I'm like, because I knocked my head. Don't you remember? Well, it was sort of like that. I had all these memories surface, but I didn't know if they were intentions to do something, anticipations, actual events. And what was really interesting, and you might think that memories are just simply stored in your mind, but they're not just stored in your mind like a computer. They're linked chronologically. And there's something very, very important in that. Because if you just break the chronology of those events and memories, you lose yourself. You can't put things together. Now slowly I started kind of building it was sort of like Memento. Everybody see that? So I started tattooing myself on the beach, right? And like trying to build like a case. No, actually I had to go find my phone and start going through and calling people. Like, I think you're my friend, you're listed in my phone. I don't know who I am. Oh, I found my ID. I guess I'm Eric Sorm. You might have heard of me. You might have seen my YouTube channel.
Wait, how much did you lose like general information or just memories?
Oh, that's interesting. It was first, it just kind of came off a really strange feeling, like almost like an outer body kind of experience. Everything looked new, and it was actually a really incredible day. It was at Zuma Beach in Malibu, and it was so exotic looking that I didn't associate it with the United States. And then I had a memory that, wait, aren't I supposed to go down to Panama or South America or something like that? I'm like, maybe I'm in Panama. I don't. It was kind of like that. So I can't really recall like how much general information. At first I had no information. It was like completely wiped clean, and then stuff slowly started to come back. I mean, within a relatively fast. Within 2 hours, I had all my memories back. I was able to figure out, yeah.
No, I was just going to ask you, like, you have to go to any kind of therapy after that?
No. No. It's just a slight concussion. Yeah, it could be quite serious. So I was quite lucky. But that shows you how important time is, and chronologies, that your identity's tied to it. It's the most familiar thing to you. It's the closest thing to you. But have you ever tried to explain to somebody what time is? Do you have, no pun intended, a hard time explaining what time is? So, you might think different after the lecture. You might recant. Yeah, these are things that we're going to talk about too. Can you drink it? Yeah. Can you pour it in a cup? Can you weigh it? You want to hear a story about, I remember when I first started thinking about this, I asked, and try this, ask little kids like deep philosophical questions, and you get like actually really amazing answers. And I asked my nephew, he was 7 at the time, okay, what's time? Is it something that you can pour into a cup, drink? No. Okay, what is it? Is it the clock? He says, no, silly, that just tells time. That's like, smarty pants. So what is it? I kid you not, I couldn't believe what came out of his mouth. A giant clock. No, he's like, he said, reality. I was like, now, to appreciate that, and we're going to get to this later in the lecture, it took Martin Heidegger his whole life in his magnum opus, Being and Time, to basically come to the conclusion that being, reality, and time are equivalent. How does a 7-year-old get that? He's like, it's reality. I'm like, who told you that? And I asked him, how'd you figure that out? It takes Martin Heidegger his whole life, one of the greatest 20th century philosophers. And he says, well, and he gives a very Heideggerian answer. Well, because you're adults, your heads are so full of all these theories and knowledge, I just see it as it is. I'm like, all right, get out of here. Out. That could be true. Oftentimes, you ever do riddles? Riddles sometimes are very simple, but very difficult because you're thinking through all these kind of complicated theories, and oftentimes it's just right there in front of you. That's why kids sometimes are really good at riddles. Yeah. We will see it is quite difficult to, the further you start thinking through the issue of time, and the more that you try to explain it to somebody, you will start to find that it's much more complicated than I thought it was. And oftentimes, people like to quote St. Augustine. St. Augustine, one of my favorite books. In fact, I made my wedding cake into St. Augustine's Confessions. That just shows you what a freak I am. It was like these places that make these fancy cakes, and it was our 2 favorite books. And it would really look like leather bound and stuff, and nobody believed it was a cake until we actually cut into it because it looked so real. But in the Confessions is an autobiographical account of Augustine, his thoughts and his conversion to Christianity. And there's a section in there where he's actually thinking about time. There's actually a funny joke that do you ever wonder what God was doing before he created time? Now, to appreciate that, anytime you use the word before, it connotes time. So really what that's translated is, what was God doing in the time before he created time? And Augustine wittily, in a comedic manner, responds, he was creating a special place in hell for people who ask questions like that. Not really, but maybe. Be careful. Look out. Okay, so in the Confessions, he talks and he's thinking about these issues about time. And so I like to begin with it because it really kind of sums up the difficult nature of time. He says, "For what is time? Who can explain it easily and briefly? Who can grasp this even in cognition so as to offer a verbal explanation? Yet what do we mention in speaking more familiarly than time?" Think about it. All your words are tensed, your whole grammar, it's all embedded within the framework of time. And you know it. And you certainly understand it when we talk about it, and we even understand it when we hear another person speaking about it. And here's the famous line, "What then is time? If no one asks me, I know. But if I want to explain it to someone who asks me, I do not know." So that's a really nice way to kind of capture the kind of paradoxical nature of time, that it seems so familiar and so easy to grasp, but then you try to explain it and you end up having a very difficult process of explaining it. Okay, so let's go first. The first systematic treatment of a science of time, although Plato talks about time and has a theory of time in the Timaeus, the real first systematic treatment of time is Aristotle. So remember, Aristotle's book, The Physics, coming from the Greek word physis, which means nature. That book is a treatment about nature. And remember, the one thing that you notice about nature is motion and change. And this is really what the book, Physics, is about, in which we get modern physics. Think about it, Newtonian mechanics is concerned with motion, moving bodies, acting upon one another. In the book, the Physics, book 4, chapters 10 through 14, he then focuses on something specific about motion, and that is time. And he begins a treatment of time by immediately connecting it to motion. But it's interesting, he doesn't say that motion and time are identical. What he says is they're related. Well, how are they related to one another? He says time is neither movement, but it's not independent of movement. What he says, okay, there is no time without motion. Although there may be motion without time. So what that means is the dependency goes one way. Time implies motion, but not the other way around. In other words, time piggybacks on motion. So that I can have motion without time, but if time depends on motion, if I remove motion, then time goes away as well. I think it's pretty intuitive, this first antecedent condition here, there is no time without motion. Now remember, what is sensation but the world moving and pressing in on your sense organs, and you perceive that? What happens when, in a sense, you anesthetize yourself? Well, the easiest way to find yourself anesthetized is when you go to sleep. Your senses shut off, so you're no longer perceiving the world pressing in on you. How accurate is your sense of time when you're dreaming? You lose a sense of time. Well, that makes sense, because it seems to me that time is dependent upon motion. It's this latter, the consequent, the antecedent. Sorry, this is the antecedent, this is the consequent. there may be motion without time. That seems to be controversial because how do we traditionally in history measure time? So what Aristotle's saying is you can have movement without any time. You can have the earth going around the sun, but no time. That seems to be controversial. That might actually lend to what who was saying that, well, is time anything outside? Or is it something psychological? Is it independent of? Then this would be false. However, the fact that you can tweak with motion and you lose a sense of time might suggest that there's a psychological component to time. Here's another great experiment. How many people have seen one of these things or been in one? Last year I did this lecture and a student brought like a whole stack of like free flotation. I guess there's one in Costa Mesa that you can go into. I think Joe Rogan popularized sense deprivation tanks as well. But what sense deprivation tanks do is, in a sense, anesthetize yourself. So think about like when you have anesthesiology in an operation. Okay, you don't want to, when you have the world moving and pressing and cutting you, let's say in an operation, you don't want to have to feel that. So one way to anesthetize yourself is to knock yourself out. Sort of like when you're dreaming. But there is also a way to anesthetize yourself without knocking yourself out, where you're still conscious. You block or shut off any outward stimulation, and therefore your senses will not be receiving anything. So one way to do that is put yourself in a dark kind of pod so you're not seeing anything. Obviously you're not putting perfumes or odors in there. It's soundproof so you're not hearing anything. But then it has the water at 93.5 degrees Fahrenheit, and they put enough salt in there that it's buoyant. And the reason why that is, imagine you close your eyes and you put your hands into the water. How do you personally tell where your hands end and the water begins? Or that there's something there that you're putting your hands into?
You either do it by touch or temperature.
That's why I had you close your eyes. Temperature or touch. So if you splash like that, Newton's third law, you're going to have an opposite reaction pushing back. Or you notice a difference in, oh, that's cold or it's hot. So if you get that equal to roughly your body temperature, then you get it buoyant enough that you're floating and not touching anything. You've basically shut off any sense perception whatsoever while you're still conscious. I had a student from this morning's class that said she'd went in one of those, and she described what happened to her exactly the way I expected. She thought that they left her in there for like 8 hours. It was only like a minute or two. She lost track of what? And she started to have hallucinations too. Part of that is exactly like what you're doing when you dream. In a sense, you're hallucinating. And the reason why is that your mind is geared to receive external stimulations from the world and process those under certain concepts and ideas. Well, what happens when you shut off the external stimuli. Your brain still works in that modus operandi, right? It's still going, and so it will retrieve memories and things from sense perceptions that you stored in. That's what happens when you dream. That's what happens when you shut off all external stimuli, is that your brain will start producing it from somewhere. And so she said she started hearing noises and started having panic attacks. Some people freak out, have freakouts and that. Now, I think you can get used to that, and then it ends up being kind of a relaxation flotation chamber or something like that. But that's all to show that, yeah, we could actually physically do an experiment where you remove any sense perception of motion and you lose your sense of time. So that's a famous Aristotle quote. But neither does time exist without change, for when it's supposed to be state of our own minds does not change at all, or we have not noticed it changing, we do not realize that time has elapsed. That's why, since solitary confinement is so awful, you basically put yourself in a situation like that. Do you know what people do to keep their sanity? Because you will lose yourself. Like I said, if you lose track of time, your identity is tied into that. You will eventually lose yourself and go mad. You have to keep track of time. That's why you see people start doing like. But sometimes they remove anything to be able to do that with. And so maybe, have you ever seen where people are like throwing the ball? It's not just to keep them from being bored. They're actually keeping time. When that's removed, I even heard horror stories of in wars and stuff where people were in prisoner war camps. They would actually use their growth of their nail as a type of calendar just to keep track of. Also, think about this. Have you ever had the experience of time going faster or slower? Yeah. If you want to see how slow time really can be, go in a room where there's really not any kind of distractions or something. Get like a secondhand watch like that and just stare and count. See how long you can go. It will become torturous. It will be the longest 5 minutes of your life. Does that suggest that time might be psychological? Well, I could tell you the answer. I'm just telling you to think about. Okay, I first started thinking about time when I was some of your guys' age. When I was your age. I was, before I transferred to the four-year college, Thomas Aquinas College, I was taking physics, math courses at OCC. And I thought, you know what? I can figure out what time is. We've got formulas for these things. And the common formula that everybody knows is the formula of your speedometer, velocity. Velocity equals distance over time. So that's telling me what velocity is. It's like when you look on your speedometer and it says 65 miles per hour. So I just figured I'll just use some simple algebra, isolate my t variable, tell me time equals this, and I'll have solved the problem at 18 years old. 19 or whatever, however old I was. So watch this. So I need to get this over here. So I got to eliminate these, correct? What I do to one side, I do to the other. So now I have time multiplied by velocity equals distance, but now I've got velocity that I want over on the other side. So I have to divide. What I do to one side, I do to the other. Oh my goodness, I figured out time. Time is distance over velocity. That's all it is. So I started to think through this a bit deeper. Well, I know what a distance is. So what does it mean to divide distance by a velocity? So I started thinking about, well, what is velocity? Well, velocity is distance over time. So let me just plug that in. So time is distance over time. Uh-oh. Have I gotten any farther? Have I figured it out? Yeah, it's a tautology. We're just stating the same thing. We're going in circles here. And the reason why is because physics formulas will not tell you what things are. They already assume it within a theory of time, a theory of physics. Formulas subsumed under a given theory function practically. That just means once you have the theory in place, the formulas are simply the numbers that you plug in, you will get the output in a universal way. So we need a theory of time. That's the first problem. Second problem. When you're driving by, let's say, Fullerton College or the Angels Stadium, and right at that instant you look down at your speedometer and it says 65 miles per hour. Is that the velocity, the instantaneous velocity you're traveling right at that second? It's an average. It's saying basically when you cross that point, if you ask what is your velocity, it's saying, I don't know. We don't actually know at that instant what your velocity is. Well, what do we know? Well, if you keep whatever that is up for 1 hour, you have traveled 65 miles. In other words, 65 miles per hour. It's an average. So we need a mathematics that can calculate instantaneous velocity. And that needs to be created. What mathematics possibly deals with that? Calculus. You want a crash course in calculus? So in other words, here's what the problem is. Using just standard algebra, I have my distance here that I cover. So change of x is the distance. Change of t is over time. So what you have here is distance over time. And what you do in mathematics is you simply make a right angle triangle here, because a right angle triangle, I can obviously, if I know the lengths of the sides of a right angle triangle, I can calculate the hypotenuse. The hypotenuse, therefore, is the average. So that would be like the 65 miles per hour. But that doesn't tell me instantaneous velocity. Notice, in an instant, I'm not going at I don't have a line, a magnitude. I need a point. And so in order to do that, we need to have calculus to compute the limits. And what we get here is distance over time is to find the tangent on a curve. So we need calculus to do that. Who are the two people that create calculus at the same time in two different places in the world? Completely unconnected. Newton. Who else? Gottfried Leibniz. In fact, if you want to see the very beginning of calculus, this issue is historically in mathematics, goes all the way back to the ancient Greeks. It's called squaring the circle. And what that simply means is, how do we get the area of a square to equal the area of a circle, because they seem to be two different types of mathematical entities that seem to be incommensurate. It's easy to figure out the area of a square. It's side times side. A circle, pi r squared, the problem is pi is not a whole number. It's kind of fudging it. So Greek mathematicians got a nifty idea of, yeah, but what happens if, since I know how to figure out the area of a square, what if I just put a square in there? Well, then I have all this remainder. But what if I just add up squares? Just keep putting, notice that the remaining area gets smaller and smaller. How many squares do you think that I need before the remaining area equals 0 and the square equals the circle? The area of the square equals the area of a circle. An infinite amount. And therefore, you need a mathematics that can deal with infinites, which wasn't present until Gottfried Leibniz and Sir Isaac Newton. So we thought. There is somebody that actually was working on this, and we thought he just didn't get close enough. Does anybody know Archimedes? So you can see he's dealing with that right there. He's working through, he just never got to it. So we thought until we discovered a medieval illuminated manuscript. Do you know what an illuminated manuscript is? It's, for example, like religious texts or Bibles or something like that in the medieval ages. They would do really nice kind of illuminations, right, with using gold leaf and paint and stuff like that. One of the most famous one is in Ireland, the Book of Kells. And what you would have, remember there was no printing press until Gutenberg, and therefore things were really expensive that you had to have. And so what people would do is you'd have to hire a scribe to do that. That was expensive. There was no copying machine. Therefore, what people would often do is they'd reuse old papers and stuff like that. And what we found is, it's called the Pamphlet, and on that was an illuminated manuscript, but we started to see there was something underneath, as if this medieval monk had painted, did illuminated manuscript on top of something. And because we had digital technology, we're able to lift that image, and guess what we found? It was Archimedes. It was an Archimedes proof in which he actually squared the circle. He had 2,000 years before Newton and Leibniz actually had figured out the problem, and it was lost due to some monk painting pictures, doodling, illuminated manuscripts on. So for what it's worth, here's just kind of the modern squaring the circle problem. This is from Newton's Principia here, and what you see is something similar. The more rectangles I put in here, this decreases. Now I can put rectangles here and then subtract the difference. And therefore, if I increase the number of those and subtract the difference, then ultimately the difference will get to 0, and the area of a rectangle, or the difference between them, will actually end up equaling the area under the curve. So that's a crash course in calculus. In case you didn't know what Newton and Leibniz look like, that's what they look like. Newton came up with a different type of calculus called derivatives. Gottfried Leibniz came with integral calculus. But there was a dispute. Newton said, how could anybody in the world be as smart as me? We've got an imposter here. This man must have stole my ideas. Nobody's this smart to come up with the same. I'm sure you've thought that too, right? No? Absolutely. So they had kind of a trial or hearing investigation at the Royal Mathematics Society, Cambridge, in which they found Newton was the winner. Here is the imposter, that Newton created calculus, and that might not sound shocking until you find out who the president of the Royal Society of Mathematics in Cambridge was. Newton. Posthumously, they award Leibniz that, in fact, he did come up with calculus completely unrelated at the exact same time, but he did not steal but he wasn't alive to appreciate the reward.
What else has he done?
Amazing philosophy. He's really a stellar philosopher. Famous for monadology. Yeah, really good. In fact, Dr. Bernier specializes, and I have another colleague that specializes in Leibniz. And we have some great conversations about Leibniz. All right, that gives us the first problem. Checked off. Now I have a mathematics to calculate instantaneous velocity. I need a theory of time. But remember, time implies motion. And motion, how do you move? What do you need to move through? Space. So you need a theory of space so that you can have concept of motion and therefore time. And basically you have two scenarios in which you could have in our universe. Either the universe is one in which it's absolute space or relative space, and I'll qualify what that means. You might be familiar with what relative motion is, or that motion's relative. For example, if anybody's ever had this experience of being on a train and you're next to another train and then you can't tell if it's you moving or the other train. What do you have to do to figure out who's objectively moving?
Something else.
You have to look outside the reference frames into, like at the platform or see the tree or something like that and go, okay, relative to the tree, you're moving and I'm standing still. So that's to illustrate that possibly motion's relative. Or remember I told you about there's some professor that's offering some type of endowment or reward that if you could prove either system, a heliocentric or geocentric universe, solar system, then you get that. Nobody's collected. And part of the problem is, again, from the Ptolemaic system, from your reference point, just like on the train, it looks like the sun's moving. It looks like this. And planets as well. Copernicus' great revolution was to say, well, what if we changed our reference point and our perspective and put ourselves on the sun? Would it look different? Heck yeah, it would. It would look, if you could be on the sun, it would look, you'd see the planets and the Earth moving around the sun. Now, which one's actually the case? Which one is the center and which one's stationary? Well, just like the train scenario, you'd have to get out of the reference frame. In other words, it could be the case that you from this, if you conceive of your perspective on the sun, it will look like this. But that's, what if you get out of that? What if you get outside of the Milky Way and find, holy smokes, in fact, it looks like the sun is orbiting, some point, and the only thing stationary in the middle, the center, is the Earth. You wouldn't know. You would have to get out of, and ultimately, to figure out this question, do we live in absolute space or relative space, or is motion relative? You'd have to exit the entire system, the universe, and get kind of a God's eye point of view and look down on. Now, there's two problems with that. A practical problem, what kind of spacecraft are you going to be able to do that? And second of all, well, what does the universe mean? Is that even theoretically possible? The universe means everything that physically exists. So let's say I'm at the edge of the universe right here. I found it. Okay. Now I'm going to jump outside the universe. I'm going to finally get outside of the universe. Okay. Aren't you happy for me? Okay, here I go. Ready? Bam. I just made more universe. It's like, okay, it's like trying to get out of yourself. It's not possible. I'm making more universe. So we got a theoretical problem. I can never get outside from a God's eye point of view. I'm always within. Okay. So start thinking right now, well, what kind of experiment could I devise to be able to tell what the difference between relative and absolute space is? But let me just give you a visual demonstration of what I mean by absolute space, or what Newton means by absolute space versus relative space. Oftentimes, science will use the notion of a cube to represent space, or space exploration, science of space. And that's because space is what's in between. And that can be visually represented by a cube. Let's say, pretend you're God, okay? And you want to create a universe. You got two options here. Are you going to create a universe in which there's absolute space or relative space? Well, what would that look like? Well, if you wanted to create a universe in which there was absolute space, as Newton says, absolute space is something kind of analogous to a container. Now, no, it's not like you actually get to the end of the universe and play mime, right? And be like, oh my gosh, I'm in a container, right? It's an analogy. And why that's absolute and objective as opposed to relative is once you create absolute space, something akin to a container, then you can place things in with objective reference points. Okay. This person is in upper, lower quadrant, this person's lower, the center, and it's not relative to any perspective because it has an absolute perspective, an absolute space. That's what it would look like if you created a universe in which there was absolute space, whereas relative space isn't really anything like a thing, but simply a relation like left and right. In other words, in the beginning there was nothing, and now you want to create a planet. Call it Earth. There's still no space. Not until you create something else. And what is space? It's simply the relation between the two objects. Therefore, it's relative. Why? Which one's on top and which one's on the bottom?
So essentially, let's say there was nothing in the universe except for one planet, and there space was relative space would exist.
Right. Yeah, that's right. If relative, let me put this. If there is no absolute space and there was only one thing created, there would be no space. Period.
This would be all of everything.
Yeah. Unless you want to be like, well, there's space between things like that. There's other objects. But just imagine it was a solid object, nothing to compare to. Okay, so this is kind of an analogy here to get you. The reason why it's relative, you can't say the Earth is on top and Saturn's down below. Because from Saturn's perspective, they could be like, what are you talking about? We're on top, and we're looking down at you. Why? Because there's no objective absolute reference frame. It's all relative. That's why you see those funny globes from the Australian perspective, where Australia's on top in North America's south. It's not false. It's kind of funny that it's like, well, yeah, it's just kind of relative that we assign the North Pole and South Pole. We could reverse it. It doesn't. Have you ever seen? It's really strange looking too, where Australia's up top, and then it looks these huge land masses down on the bottom. I actually kind of like the looks of it better aesthetically. Maybe it's just because it's exotic looking. Whoa, I've never seen that before. Of course you live there. What are you talking about? Well, not from that perspective. Okay, so that's kind of to illustrate the difference between the two. This is complicated. I mean, how the heck would you figure out either a physical experiment or a thought experiment in which you could determine, well, what universe do we live in? Absolute space or relative space? And we need that. We need that as a theory if we're going to have this stuff. Theory of time. Does anybody have any ideas of an experiment you could do? Either a physical experiment or a thought experiment? Or you could take the third option, there's no way you would ever know. Well, not in thought experiments. Remember we talked about, in terms of philosophy, empirical facts are the lowest level of knowledge. So it might be a fact in this universe there are no pink flying elephants. Okay. But it's not logically impossible. So that means that logical truths are far stronger than empirical truths, because logical truths hold across every possible world. So when you do thought experiments, you're not actually taking your Erlenmeyer flask and Bunsen burner and going up. You are doing modal thinking, and the only conditions that you need to satisfy for thought experiments is that you don't contradict yourself. Because contradictions are wrong across every possible world that you can think of. So therefore, if you're able to derive through a thought experiment by way of not contradicting yourself, or either by a reductio ad absurdum, then you can import that principle into our physical universe and be like, this must hold true. Why? Because it holds true for all possible worlds, and we're one world among many logically possible worlds. And then the highest would be truths would be metaphysical truths. They're even higher than logical truths. So yes, you can use anything you want in the thought experiment as long as you don't contradict yourself. How many people think there's no way you can figure this out? How many people want to see what Newton does? Newton figures it out. He uses a thought experiment. It's called the bucket experiment. Now, you have only two options, so you could even set this up almost as a reductio ad absurdum. The thought experiment, because you're trying to figure out in which one does it generate a contradiction and which one does the thought experiment make sense. So you have two options. Either I can think about this experiment happening in absolute space or relative space. So it'll start off like a riddle. Imagine, if you will, that there is Nothing. No objects. I'm going to give you 3 objects now. A rope, a bucket, and water. Now obviously you couldn't make this work empirically because the rope needs to hang on something. But in thought experiment, that can work. So you have the rope here tied to the bucket, and there's water in the bucket. What happens when I start turning and giving this bucket motion? The motion will then be transferred to the rope, and you'll start to see that that's stored as potential energy, kinetic energy, and it'll get harder and harder as it kinks up to turn that. Okay, now I can feel the force pushing against, because Newton's third law. What happens when I release? Yeah, that's going to release like that. And what you're first going to see is the rope and bucket are moving together. Now let's first define what motion actually is. Motion is a change with respect to something else. So first premise, you have 3 things and only 3 things that you can reference in this thought experiment: a rope, a bucket, and water. Premise 2, we have motion of the rope and bucket. They're both moving together. Not with respect to each other, but together. So if I was like that. Now at first, that motion will not be transferred to the water. So everything's moving, that's why it's staying still, and it's like the bucket's moving around the water. But soon that motion will be transferred into the water, and the water will start moving with the bucket and the rope. And the water's going to want, as it's moving in a circular fashion, it wants to go out. Just like if you had a tennis ball on like this, just like the experiment of centripetal force, you have 2 motions, a side motion and an outward motion, of which the vector ends up calculating the circle if you added enough of the triangles up. It can't go out because the bucket's preventing, so the water starts to move up and form a concave surface. So Newton asks, why is the water becoming concave? And you say, because it's moving. Then he asks the real question, moving with respect to what? So premise 3, the water is moving. If it's moving, it must be changing not with something, but with respect to something, something else. And you only have 3 things that you can choose from: the rope, the bucket, and the water. The water is moving, therefore it's changing with respect to what? Is that true? The bucket? When you're driving in your car, do you say I'm moving with or changing with respect to my car? Or are you moving with your car? With the car. That's what the water is doing. The water is not changing with respect to the bucket. It's with the bucket. It can't change with respect to itself. The rope's moving with it too. Where was it? You have to conceive of this experiment happening in either one or of the 2 scenarios. Does it make sense that the water and bucket and rope are all moving in relative space where there's nothing? There's nothing to move with respect to. Now imagine I empty this room of everything. I've got this pen. It's pointing towards what? I'm going to move it. Okay, it moved with respect to what? Or changed? And how do you define space? Yeah, somebody said it. the walls. So this is changing or moving with respect to it's no longer hitting the north wall, it's now west. So the water is moving with respect to what? Absolute space, we just proved. A priori. How cool is that? Now, to appreciate how brilliant Newton actually is, he knows that to be able to empirically determine this, he would actually have to get outside of the universe and look down from a God's eye point of view. That's theoretically and practically impossible. So what does he do? Well, you have to appreciate what Newton thinks about the physical universe and about God. He believes that God has left his prints on his creation, and that the language of God is mathematics, and that what he's able to do is take you where no man can physically take you. Through this thought experiment, and therefore by constructing, once you have absolute space, he can then therefore have formulas like the inverse square law, gravity, which universally apply to every single object across the entire universe. That's what he's doing. In a sense, what he's doing is he's attempting to lift you up into the mind of God and see things in the created order the way God would see it through mathematical language, which you could never obtain empirically whatsoever. That's his brilliance. That's the brilliance of the work, the Principia. Nobody was ever able to do something like that. And so, yes, a brilliant mind. Now, of course, that's going to be overturned with Einstein, or at least a rebuttal will be formed. But we're not there yet. We need to turn, shall we turn to a philosopher? How about a contemporary philosopher of Newton? Immanuel Kant, do it. Yes, sir.
Okay. With regards to the
Bucket experiment?
Yes. I was thinking about it, kind of trying to apply some earlier things that we learned in philosophy.
Right.
Causes, because physically speaking, the bucket is the thing that causes the water to move up the bucket because of the force that it
Right.
applies on the water. Therefore, it would if the bucket is caught, because if the water and the bucket are moving at exactly the same, like they're in the exact same.
I'll just
motion.
rewind so you can use the visual image.
Yeah, if they're moving with the exact same motion, like they're exactly the same at exactly the precisely the same moment,
Yeah.
then the bucket can apply no force on the water, and the water does not change its position. Meaning that in order for the water to change position, to spread up the bucket, it has to be in motion that is just slightly different than the bucket itself.
I don't think so. Why? I'm not sure.
It's dealing with gravity and
Because we could actually physically do that experiment. We could add more things where we get... Now, notice they don't start off that way. So let's say first we move the bucket, which moves the rope. Then we release it. And then, let's say the rope infuses the motion to the bucket. So first, second, third.
Right.
Okay, once we get to the third step, now they're all moving together. So we could actually physically perform this experiment. The water is going to want to go out.
Right. Physically speaking, when it's the reason, if you have to consider the water not as one thing, but as many things.
Yeah.
Because it is many things. So it starts moving in an upward direction because it's the outward motion is not out, but it is like at each, like for example, if the bucket is here, the water is here, it is going this way. The curvature of the bucket makes it change direction. So it is, so to speak, there must be a difference in them in order for the bucket to apply that force on the
What if it was
because
Jello? Would it make it easier to think through? Because you're maybe thinking of water because you're thinking of the molecules and the motion being transferred. Is that kind of what you're thinking?
Well,
I think because the purpose is just as soon as you get whatever the substance is in the middle to move with the bucket. Okay.
You're just saying once the water and the bucket are moving at the same speed, it shouldn't travel up the side anymore. But that's not going to be the case because centrifugal forces up.
What I'm saying is that physically speaking, that although it might not, or although it may appear that the water and the bucket have the same motion, they, in actuality, do not have the same motion.
Well, I think the concavity is somewhat incidental. That's why he goes to say further. Like, well, why is it being concave? So the real important thing, that's why I was saying you could use Jello. Jello's not going to go concave on you. It would still move. So the idea is just to have three things that are moving together. If they're moving together, they're moving with respect to something. So if you could just get in the thought experiment or a physical experiment where all three things are moving together, I think that would suffice for the experiment. But yeah, that's an interesting question. Then why does he use water?
The question is, why didn't he use the marker and use the bucket?
Because he's not as smart as me. So now you know who the real smarty pants is? No.
Because that was a lot easier.
That's really prideful of me. Why did I say that? That's so stupid. I'm actually really stupid. Yeah. Oh, great point though. Yeah, ask more questions. It's good to work through the lecture. Now let's think about Immanuel Kant. Immanuel Kant thinks about space and time very differently. Seems to me that Newton thinks about space and consequently time as something like a container. It's out there, independent of. Well, we've got this famous line from the Critique of Pure Reason from Immanuel Kant, and he says, space is not something objective. It's not an object. It's not out there. And it's not real by that standard, by third-person objective standard. He's not saying it's totally illusory. So he starts going through this similar questioning that I questioned my nephew. Can you pour it in a cup? Can you drink it? In other words, is it a substance? No, he says it's not a substance. Is it an accident? That doesn't mean like a car accident. Remember the Aristotelian language? Essential properties versus accidental properties that adhere in a substance. So, is it something like color, heat? No, it's not an accident. Is it a relation? Is it like left and right? Immanuel Kant says, no, it's not a relation. Instead, it's subjective. That doesn't mean like subjective morality. It means it's in you, the subject. And it's ideal, meaning it's connected to ideas. And it originates from your mind's nature. Well, how is it that we're all getting here at the same time? When I say that class starts at 6:50, actually that you guys don't really get here all at the same time. Touché. No, but you understand what time, you know that you're late or you're early. How is it if it's subjective? Because remember we talked about taste being subjective. What was one of the things that you dislike? One of the foods, name?
Strawberries.
Really?
Strawberries.
Interesting. I've never met somebody that doesn't like strawberries. Is there anybody else that doesn't like strawberries?
Coconut.
Coconut? What? Celery? Come on, more. This is kind of interesting.
Avocado. Yeah, I like avocado.
Onion.
I'm with you on onion. I have to cook onions to eat them. Peas.
There was a while for me where I hated things made from chocolate. It's like chocolate cake, chocolate pie. I hated all that, and then like the past few years I've been.
His taste changed.
I was like,
Is that because the chemical composition of the substance changed?
Nope.
It's like, wow, what did you do to it? It's like nothing was done to it. Something was done to you. Something changed in you. And the way that I might experience coconut is going to taste very different than obviously you do. You're repulsed by it. I find it very attractive, very pleasurable. Well, that's subjective. We're having different experiences. Well, what's puzzling is that Immanuel Kant says that time is subjective. But it's subjective, then shouldn't we all have a different experience of it? But we're all having the same experience. Well, he says, well, it's because you all have the same kind of thing here, a mind. Assuming that you don't have some type of mental health issues, because that will actually affect the way that you perceive time. Also, another something that you can do to your mind that will really change the way you experience time. Get drunk and take drugs. Actually, don't do that. If you do, this is what will happen. Your time will obviously change. Your perspective of time.
oh, yeah, perspective change, but it's just it's more about like the time will come. It's why the end part is because you're about.
Well, Kant might just be like, well, that's because we're all experiencing it together in a different way, and we decide that your time's up. It was time for you to come. But that doesn't mean that there's times outside of you, not according to Kant. We just say, yeah, but how is it? Well, he doesn't say it's relative, he says it's subjective. Now, the reason why you don't experience it differently like other subjective things is because you have the same type of mental nature, unless you don't, and then you're going to experience it different. And that it operates according to a law-like structure, in accordance with a stable law as a scheme. Now, let's think about the way laws work. What happens when laws are always in a conditional, an if-then statement. If you see something that looks like this, what are you supposed to do? You don't even need any writing. It could just be like a sign like that. A red octagon. Yeah. But that's just for you, right? That doesn't apply to me. Like I always tell my wife, these laws are just suggestions for me. They're not. No, it's an if X, then Y universally. That is a law-like structure. It's a conditional, and if this, then that. For all. Well, Kant's saying your mind works like that. It has the same nature, and it has a law-like structure. If you perceive this, then produce this across the board. Now, you first have to understand that remember the difference between the ancients and the moderns. Starting with people like Descartes, who mechanized nature. And then this goes and is heightened with Sir Francis Bacon, who's rejecting Aristotelian forms in nature, that there's any real stuff out there. There's no real apples or anything like that. No nature of appleness, dogness, humanness. Everything is just molecules in motion. Kant is an inheritor of that. The Enlightenment is the inheritor of that. Now, that simplifies, and that's not necessarily the right way to go, but it simplifies things. Why? Because remember, they remove Aristotle's four causes, and they only keep one of them, and that's efficient mechanistic causality. So once you just have molecules in motion, then you can simply apply mathematical vectors and formulas of forces to calculate and predict if this force, then it will, given this direction of velocity and force, go here. So obviously you can see contemporary modern science booms at this point because it's inherited the kind of Baconian modern rejection of living essences or forms in nature. So Kant embraces that too. So this is exemplified in a contemporary who was right before him, David Hume. And David Hume says the world is just a sense manifold. A manifold is something that's like not connected. So if you think about what does modern science really tell you an apple is? There's no red. The world's black and white according to modern science, and it's just molecules in motion. Well, how the heck is it that I see this if the world, so if this is in my mind, but the world really looks like this, how is it, how do I get this from that? Kant has an answer for that. So just think in terms of modern science. What is red? This qualitative experience. It's nothing more than the wavelength of 700 nanometers. So that when that hits your eyeballs, you have an if this, then produce, this would be my thought bubble up here, that, the experience of red, the experience of extension. But really the world in itself is a sense manifold, nothing like that. And that's so what is space and time? He says it's nothing outside of you. He was smart enough to know that, like Plato and Aristotle, the principle of knowledge is form. The question is, well, where do forms exist? Remember, Plato's like in the Platonic heavens, and Aristotle's like, no, they're in matter. But both knew that in order to understand and for something to be real, you need form. What Kant has done is something called the Copernican revolution. Because just like Copernicus, who says, okay, the old view is that our perspective's from Earth, but what if we do a revolution and we put our perspective on the sun? Then it looks like a heliocentric, very different. So how is that analogous to Immanuel Kant's, why do they call it the Copernican revolution? Because he's doing something similar. The old way was to see the forms in the world. And Kant embraces the modern picture, the Humean sense manifold. There are no forms. It's nonsense, these guys think. Well, then how am I going to explain knowledge? Knowledge. He does a revolution, puts them in the mind. They are now the forms of the mind that categorize your sense experience. So he says, from the Critique of Pure Reason, space and time belong only to the form of intuition. That doesn't mean I have a hunch, but it's what makes possible knowledge and sense experience. And therefore, to the subjective constitution, that's you, how are you constituted such that you can apprehend the world? Guess what? The forms of space and time. Without which these predicates, so when you say this, the apple is red, could not be ascribed to anything at all unless you had the forms of space and time within your mind that produce a law-like structure according to your nature, the nature constitution of your mind, such that if the world comes in a certain way, I'll produce this particular experience. But there's nothing out there in the world. And I'll give some concrete examples. So if you open up your brain, it turns out that's what your brain looks like. You have all these different categories. And so there are no forms out there according to Immanuel Kant. By the way, you've got to find me some of these philosophical action figures. I will pay you money. And they actually come with explanations. With Copernican revolution, action spins his head, changing the direction of epistemological fit from mind-world to world-mind. How cool is that? Something every child can understand, right? The Copernican revolution, epistemological fit. Are you kidding me? Heck yeah. So if you find those, let me know. That would be cool. Collect them all. Like Pokemon, but it'll be for like Immanuel Kant, Aristotle, Nietzsche. Check him out. He's got his muscles too. Looks like he's got like tiger stripes too. I didn't know that about Immanuel Kant. Learn something new every day. Not only does he have epistemological fit in the Copernican revolution style, he's got tiger stripes. Okay, so again, these are the categories in which you perceive the world. And it's all ordered under space and time. But let me explain some further background behind Immanuel Kant. He has two worlds, the noumenal world and the phenomenal world. Ding an sich in German, the thing in itself. Sort of like the way God would see things, the things as they really are in themselves. That is the noumenal world. And guess what? You have no access to it. It's beyond the world of appearances, the way things appear to you, and therefore you have no access to the noumenal world, the world as it really is in itself. Well, what do you have access to? The phenomenal world, the way reality appears to you, but not the way that it exists in itself. For example, and he says the phenomenal world proves the existence of the noumenal world, even though you don't know what. Why? Because every effect, by principle of sufficient reason, has a cause. Okay. So imagine this. Imagine you have an habanero, or the California Reaper pepper. No, Carolina Reaper. Yeah, I almost said California Reefer. Imagine you have the California Reefer. Forgive me. The Carolina Reaper. It's really hot. And then you have the ghost pepper. You eat that. And then you produce this phenomena in your mind of, oh my gosh, 190 degrees Fahrenheit on my tongue. Or maybe hotter. I don't. Now, do you assume that, my God, that pepper, if I actually put a thermometer in it, would be 190 degrees? There is no quality of 190 degrees the way you experience it in the pepper. What do you have? You have something like phenomenal. Now, it happens to, we have a scientific account that says, well, it's actually the acids that are producing that. But you can extrapolate by analogy. Imagine you didn't actually know what and really science is attempting to kind of discover the way things really are in themselves, because nature kind of hides itself, doesn't it? You kind of have to explore and dig and investigate to find, well, what's really going on under the surface. Now imagine Kant's right, and it's like, no, you just don't know. You won't ever. Then all you would have access to is your phenomenal experiences. Well, how is that knowledge? Well, he just redefines knowledge. As long as you have a causal, law-like relation according to the forms of space and time, i.e. the constitutions of your mind, and that's universally across the board, that's good enough for knowledge. So think about it this way. How many times have you looked up in the clouds and you're like, wow, there is a dragon. Oh, it's actually a mountain. No, it looks like an apple. How many people have had that? Or it looks like there's a face in the carpet. Is that because there are really apples and faces and...
Yeah.
Well, why are you seeing that? Because you have these categories. You have facial recognition patterns constituted within the structure of your mind, so that when there isn't anything out there, your mind will still assemble it in the same. And you can get people to, it's like, I saw this with like, do you remember the fires? I swear to God, it looked like demon faces in the, and I was like, am I crazy or something? Am I seeing, I'm like, I asked my wife, what do you, she's like, it looks like a demonic face. Am I right? Okay. A Kantian explanation of that would be, that is your mind's constitution when there is nothing out there to recognize and impose these patterns onto. So I find that's sometimes a helpful example. Questions about that? So if you compare the two, Kant versus Newton, which they were contemporaries. In fact, Kant wrote the Critique of Pure Reason to save physics, because he knew that if David Hume was right and everything's just a sense manifold, there is no knowledge. Why? Because as David Hume points out, there is no causality. You don't sense causation. And everything's restricted to sense impressions. Oh my gosh. Look at this. Let's just hold that up for the camera right there. How cool is that? Nice one, Joseph. Welcome. This is Joseph, the physicist professor. You can correct me when I err on my Newtonian mechanics and Einstein and Galileo, but I doubt I will get it wrong. But if I do,
I got
you got me. Okay. You cannot have science unless there's causation, and there is no causation in this world. So that's why Immanuel Kant, being friends with actually Newton, attempts to salvage science from the grips of empiricism, radical empiricism, by actually coming up with his transcendental idealism. So Immanuel Kant's kind of like an empiricist, but also a transcendental idealist, because he's using the categories of the mind to establish where's causality. It's not there, it's in here, according to the subjective constitution of your mind, which is law-like, and it holds across the boards. And it, like that picture, are the categories in which everything's sensed and processed. If you sense that, then produce this stuff here. So Kant, space and time are not out there. Time does not exist out there. It is not objective, it's not real in the objective sense of being extramental, but rather it's completely in your mind. And it's exactly what constitutes knowledge and what you would call reality in any predicates that you would make. It's the forms of intuition that depend upon the subjective constitution of the mind. Whereas Newton, space and time are not in here. They're out there. Something like you said, absolute space, which is like a container. Okay.
They actually they're both right.
Is that true? And how?
Because we can imagine time, but we know time passes on, even when I'm out, when I'm in the surgery. I don't remember anything.
Well, that's because there's other minds to keep track of. There's other minds, and so if time exists only in the mind, I'm just going to play devil's advocate. The reason why time goes on when you go into surgery and you're not aware of it is because there's other minds. If you canceled all minds, there would be no time, according to Immanuel Kant. And actually, and for Aristotle too, because motion and time are not the same. Time is dependent upon motion. But yeah, it's not just like, oh, it's just in me. That's why Kant says it's subjective, but it's universal. Because your minds have the same sort of nature and they operate by the same law-like structure that operates as a scheme for producing the phenomenal experiences. Okay. Shall we critique Newton? Okay, notice in Newton, would you open your Newton book to page 508 and sing with me the hymn of the inverse square law. La! The law of motion with me, would you please? And would you pass around the offering plate? That would actually be cool. Then I'd make much more money as a professor. Offering time. Okay. Well, notice in what kind of mathematics? Speaking of centripetal force, there's the proof. What kind of mathematics does that look like right there? Geometry. And in fact, Euclidean geometry. So what Newton's using is Euclidean geometry to describe the physical world. Now, there might be a potential problem with that. Euclidean geometry is two-dimensional. What do I mean by dimensions? Two mathematical planes. Let's just do a typical geometrical shape. What mathematical planes do I have? A horizontal and vertical. Okay. What does this world look like to you? Does it look two-dimensional to you? Sometimes. When I drink too much, sometimes it does look.
Well, I mean, yeah.
It's three-dimensional, right? There's a potential problem here that we're applying two-dimensional mathematics to a three-dimensional world. Now, Euclid starts his science of geometry with some basic principles and axioms, definitions. The point is that which has no part. Let's see if I can find the... A line is a breadthless length. The extremities of the lines are points. A straight line is that which lies evenly with every point on itself. The surface is that which has length and breadth only. Okay, blah, 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 blah. Gets into angles. Okay, now we get to postulates. That you can draw a straight line from any 2 points. Okay. What's the shortest distance between 2 points? Straight line. Also,
Unless it's a wavelength.
trying to find, if I have a straight line and it's perpendicular at right angles I'm just going to, because his language is a bit archaic, I'm just going to explain what he's saying in one of the postulates. Then line AB is what? Line AB is parallel to CD. Okay. If I draw out line AB and CD indefinitely, will they ever intersect? No, because they're parallel. Okay. Those are some of the basic axioms, definition, and postulates that make Euclid's geometry work. And then we get non-Euclidean geometry. Bonolo, the very first thing he'd do is going to refute Euclid. Is the shortest distance between 2 points a straight line? And if so, what's the fastest way for you to get from Los Angeles to Paris? A straight line? What do you typically do when you on the weekends when you fly to Europe? What do you typically do? Idiot. If you were to fly to Europe, what typical route would you take? Parabolic arc. That's actually the short. So guess what? Given 3 dimensions, the shortest distance between 2 points is not a straight line. And what do you think if I put on a funky 3-dimensional object two parallel lines and drew them out? Would they possibly intersect, given the shape of the structure? Yes. In fact, this is how he starts. He refutes that. Why am I bringing that up? Because this is going to be necessary for Einstein's theory of relativity. A criticism of Euclid's geometry, and therefore a negation or rejection of Newtonian physics and mechanics. And therefore, you need to replace it with, we need a mathematics that can deal with 3 dimensions. But 3 dimensions only gives me space. I need one more dimension. I need time. Now, how the heck do I visually represent? I think I've run out of, on the 2-dimensional board, I've run out of ways of representing dimensions, mathematical planes. And by the way, when you hear physicists talk about, like, we now have 9 dimensions, okay, that's not like Warp Worlds and Mario Brothers or something like that, where it's like, oh my God, I went into another dimension. Wow, right? They're mathematical planes, okay? So it's not as exciting as it sounds. How do I represent on 2-dimensional paper or a board 4 dimensions? Well, one way is to superimpose another dimension. So clearly, that's a different space. But what if I overlaid, so if this is 3D, 3 dimensions, and this is another dimension, how do I add that? I superimpose it onto the spatial dimensions. So Einstein begins with this. Every point in space, different point in space, is also a different point in time. So all of you are in actually different times. How is it that we're experiencing what would be perceived at the same time? Yeah. So it's sort of like the way that you perceive time and things moving is obviously by light. We shut the lights off. You're not going to be able to see anything. You're going to be like the sense deprivation tank, and you're going to lose a sense of time. Okay. I drop this, and you see that as what you would pronounce as at the same time. That's not true. If this is true, you're actually perceiving it. It's happening at different times. It's just imperceptible. Why? Well, light's freaking fast, and the distance is really short. I mean, think about with like, I don't know, a bullet travels what, 700 to 800 miles per hour? It's not instantaneous, but if I fire that off, you'd perceive that hitting you or hitting the wall, almost instantaneous. Well, how do I tell that it's not instantaneous? Make a long distance. So that's why we see in the Hollywood movies, the sniper, right? He's doing the 1,400 yard, 1,600 yard shot. What happens? Is it instantaneous when he fires? It takes some time. And actually, what happens? The bullet's going faster than the speed of sound. So you'll see the guy, then it's, that's why, what is the speed of sound? 800?
343 meters per second, so 300 miles per hour, so then would be, yeah, let's say 720.
747 or something like that. So if you go faster than that, that's why you see like jets, that they're going faster than the sound wave.
Yeah. So what happens if you travel right in front of it? Would you constantly hear the sound?
Yeah, of course you'd.
It would just be nonstop.
Well, what happens when you're flying in an airplane that's going below? It's like, wah. You're like, just get ahead of the sound. Dang you. Right?
So if you run to the front, right?
What does that mean when you talk that your sound words are behind you? You're like, oh. God, I got that. Almost forgot what I was going to say. Okay, so in 1915, Albert Einstein first proposed this theory of special relativity. So there are two theories in this book, special and general. I'll talk about that. But again, for that to work, you need 4 dimensions. And that means that every point in space will be a space-time point, a different time. So again, just like with the gun, it seems instantaneous because light's much faster than 747 miles per hour. Okay. And the distances are so short, everything will be perceived as instantaneous. But if you drew out those distances quite long, you'd actually be able to see that, in fact, that's correct, that it's not instantaneous. Okay, it's going to take, remember, in order to see something happen, the light's going to take time to hit. So over longer distance, you will be able to see that it takes time for light to travel. All right. Let's see. Okay, let's go into the theory of special relativity. So to say that things are relative, remember, it's a rejection of Newton's absolute space. So in absolute space, all mathematical formulas apply objectively to every object in the universe. So motion, space, and time are all absolute and objective versus relative. So he's going to use a series of thought experiments, of which you could actually physically do, to illustrate, in fact, no, space and time are relative. Okay? And the way you got to do that is you got to hold one constant and see if the other changes, and then vice versa. So in this, we've got Joe Schmo in the train. And I guess he's throwing a ball up and down. Okay. What we're going to hold constant is time. What does that mean? Well, we have 2 reference frames here. We have Joe and Jane. What that means to hold constant in both reference frames will assume they're in the same time. They're experiencing the same time. And then we're going to see, given that assumption, what happens to space. Okay, first focus on Joe's space of the ball. So he's traveling in the carriage here, the train, and he's throwing the ball up and down. What does Joe perceive? What is the ball tracing out in space? Yeah, a straight vertical. Okay, now look from Jane's perspective. The train's moving like this past Jane. What does Jane see? Does she see the ball moving up and down? She sees this. Just like if I went like that. If I'm giving a motion, I'm giving two motions, right? So there's a vector. Okay, she's going to perceive that. Here's the question, well, what is the ball actually doing in space, objectively? Is it going up and down, or is it making a curve? Who's seeing it correctly? It's relative. There is no objective. It's doing both. It's both. That seems paradoxically because you already assume that space is objective and absolute. But this shows that when you hold in two different reference frames at the same time, they will both be, the ball will be both traveling and tracing out a vertical motion through space and a parabolic at the same time. Why? Well, when you hold time as constant, space is relative. Now what happens if I hold space constant? What happens to time? So this is from chapter 9, from the experiment of the relativity of simultaneity. So something that happens at the same time is simultaneous. And what we have here is we're going to have two different reference frames. Joe, and let's say, should we put Jane in the train this time? Okay. Now, how do I get space to be constant in both? Well, that just line these two frames up. Okay, so when they're at this point, the distance between here and here, all the distance will be equidistant. Okay. Now, consider Jane in the train. And right as she lines up the space with Joe, two lightning bolts hit point A and point B. Okay. So what that means, it's going to take time for that light to hit. Now, once you hold the space, you're no longer conceiving them moving. So you're considering it having a velocity because you want to think about time. But at that point, it's going to take a particular time for that light wave from the lightning bolt to hit Jane's eyes. And at the same distance, right when they're lined up, another lightning bolt hits. So it's simultaneous. Bam! Okay? And likewise. So from your perspective, the only thing difference in this, okay, is simply the velocity. This train is traveling 3/5 the speed of light. You are not traveling with any speed or velocity. Therefore, it will take the same time to cover equidistance. So therefore, you see both lightning bolts what? At the same time. Freeze frame, keep the velocity, keep the distances the same. What does the Janie see in the train? Okay, A, then B. Why? No. That means the distance would decrease. If you're moving, so you're thinking it like this. This is kind of counterintuitive. Okay, so I'm moving towards you, or if I'm moving towards like this, okay, it's going to happen, or how about you throw this at my face, okay? It's throw that Coke fan on my face, okay? It's going to occur, I'm going to see that hit my face a lot faster if I jump into it, right? But I'm decreasing the distance. You got to hold it the same. You got to hold it the same as this person. So why is Janie not seeing the lightning bolts simultaneous? Because we're assuming she's not getting any closer. We're keeping that, we're holding space constant. So that would be the intuitive. That, well, because she's getting closer. No, but we're assuming we're holding the distance. We freeze framed it. What's that?
Why are we assuming?
So we can reveal something about the nature of time. Remember, in the previous example, I held time to be constant, i.e. the same in both reference frames, and then something was revealed about space, i.e. that it's relative. So now I want to do the reverse. What happens if I hold space to be constant? What do I find out about time? Time changes. The space is the same. It will have to take, again, if this was freeze framed, you would assume it would take the same amount of time to hit the eyes just as it would you. You see it at the same time. Janie sees this, not because she's getting closer, because she's traveling faster, because she's approaching the speed of light, time changes. Isn't that interesting? If you hold space constant, time will change. In fact, if you speed up to the speed of light, you can see what happens. There's another experiment here called the time dilation twin paradox. So it's going to use this principle. Okay, imagine you have two twin brothers. I don't know, give them some names. Jacko and
Phil.
Blockhead. Twin brothers. Okay, Phil and who? Jacko. One's an astronaut and one's a used car salesman. He's like, I'm selling you my used space car. It goes the speed of light, or pretty close. And let's meet back in a year. You go fly around the universe at the speed of light, and you come back in a year. So let's say he sets up a rudimentary clock. It could be, remember, you can make a clock just by bouncing a ball up and down. So 1 second, 2 seconds, 3 seconds. Well, you could do it with like a light too. So every time this light hits the mirror and comes back, it counts a unit out. So remember going back to the first experiment, the train, right? It's like the ball. So that's his clock. So he's like, okay, set your clock. And let's say he has his clock set to meet you back here in a year. He comes back in a year, and his twin brother's 10 years older. What happened? This would actually happen. If you took off in a spacecraft and came back to see us, we'd all be 10 years older. Well, think about this. For every one of this, from that perspective, what is she seeing on Earth? Because you have a motion. Now imagine multiply that by.
But it's just opposite.
What's that?
The observation of the angle.
Could be.
How
But,
does it manipulate time?
well, because space and time are relative. Remember, every different point in space is a different point in time. So if you hold this points in space constant, time will change given velocity.
So you're saying, okay, go back to the old diner, that in 1 year, time would speed of light, brother,
1 to 10.
and to this one dude, it would only be a year, and this other dude is.
It's not just seems. Because when you get back, he wouldn't just say, man, it felt like 10 years. He's actually 10 years older.
So you're telling me these human cells are not.
Time is slowing down. The faster you get to the speed of light, the more time slows down. And not your perception of time. It actually will slow down.
So your human cells slow down.
Mm-hmm. Now we thought that this was all kind of theoretical until, guess what? Do you know what the International Space Station is? Okay, now it doesn't go anywhere close to the speed of light, but it's pretty fast. It goes 18,000 miles per hour. Yeah, that's. So what's interesting is we did a similar scenario. So imagine this is not going the speed of light. It's going 18,000 miles per second. We could still do the same thing. You set an objective clock, one in the spacecraft and one. In fact, this is what we did. And it wasn't 1 year. It was 6 months. Guess what happened when the International Space Crew came back down in 6 months? There was a difference in time. Actually, they aged 0.007 seconds less than the rest of us on Earth, objectively. And guess what? If you do the math, if you calculate 18,000 miles per hour is to, let's see, to 186,000 miles per second, multiply that by 2 so that you don't have 6 months but 1 year. Guess what formula you get? 1 to 10. Confirmed. The faster you go, time will actually change.
The light never ages. The photon will never age.
So light actually in Einstein's physics is constant. So light can't change. And actually, that's a good point. Light actually determines both time and reality. Not just what you see of. So it's kind of like a space-time. That's why when you look back at, when you look out in the sky, you are looking in the past.
Makes sense.
But it gets even, that's because you're thinking, well, it takes time for it to,
Like, travel.
yes. However,
See, I started smiling minutes ago, but then
yeah.
stopped.
But it's not just seen, it hasn't happened. So all of reality takes place here. The realm of the real. Okay, in this light cone. This is the future, which doesn't exist. Again, you have to put it in terms of it all. The vocabulary all changes. According to my reference frame, what is before the light is not existent. The past is where the light has been. Okay. So the now, what's real, is contained within light. So what that means, all of this follows from the assumptions, the starting points. If you're in a different point in space and we're using non-Euclidean geometry in the context of relativity, you are in a different time. It's just, I can't perceive that because light's so fast and it's such a short distance. But what that means is, again, I'm not just perceiving. So if there was a big supernova, that kind of looks like a supernova, right? Yes. Okay. So from its reference point in space, it's happening, okay? And then it's gone. And then that reality is actually traveling, not just the perception of it. It's not like a sound wave where it's like this happens and that's the real thing and then you just hear it later. The reality is within the light. And so if you caught that exploding, okay, that would be happening for you right now. It would actually be exploding. If you change your reference point because it's a different point in space and time, it's already gone. It's not just your perception. This is going to get even weirder. Light seems to at least determine, it's almost kind of like theological implications of this too.
Like, it kind of is like past spot where like it's not that until you look.
Yes. Yes. Schrödinger's going to obviously pick up on this stuff too.
Is there anybody today at all that?
Well, it depends what you mean. You mean disagrees with?
Yeah.
Yeah, of course there's people that always disagree with. You can always find a naysayer, can't you? Nay. Nay. Let me first talk about the difference between Newtonian notion of gravity, and maybe this will help explain, and Einstein's. When Newton introduced his notion of gravity, he was accused of introducing occultic properties into science. And the reason why is because traditionally in science, the way that you knew that two objects acted upon each other is by contact. And you have this famous phrase all throughout antiquity, nature abhors a vacuum. You can't actually find true empty space. Why? Because how could you move something if there was space in between? There must either be a medium or they must be in contact. So in order for this to move, well, if Newton comes around and says, well, what's gravity? Okay, that the Earth is acting on the moon from a distance and pulling it in, it doesn't fall into us because it's also given another motion too. Now, what do you call it if I start doing this stuff? Moving objects from a distance. Are you going to be like, my God, he's doing science? Be like, he's practicing occult, right? Witchcraft. That's why, remember I showed you that video, that prank with a Carrie, where they set it up and the guy spills coffee on. She's like, yeah, and like throws him up against and all the books fall. Nobody in that room was like, amazing science. How did you? Praise be science. Remember that South Park episode? My logic. Praise be science. Nobody was saying that. They were all thinking she was like Carrie and like possessed or something, doing occultic. Well, that's kind of what it sounds like when you say that objects are acting from a distance. The Einsteinian position of gravity is very different, and in this sense might be considered a better physical theory of science. It treats space-time as a fabric. What happens when I put mass on a fabric? it bends space-time. Now, really, you kind of almost have to think about it, because space-time is 4-dimensional. So 3 dimensions for space, and then each point is a point in time.
If you're looking at it 2 dimensions, you look at it,
It's almost like putting in Jello or something like that. And then mass will curve space-time, the space-time curvature. Now, notice if an event occurs at this point, it's space and time. It will take time to travel to this point in space. How fast? The speed of light. So that's why if the sun were to go out, extinguish itself, or blow up, not only would you not see it happen for 8 minutes, it would not happen for 8 minutes. From your perspective on Earth, it will not happen for another 8 minutes. Okay, just think about that for a second. Now, why might this be a better theory of gravity? Well, if I have a marble representing the moon and I drop it, what's going to happen? It's going to roll down. Now, that's gravity. And I don't have to explain it because it's mysteriously another object is acting on another object from a distance. No, it's because there's a physical fabric of space-time reality in which when you put a mass object, it curves that, and therefore objects will tend to... Now, why doesn't, again, the moon fall into the Earth? Because once you give it, kind of throw it with another velocity, it comes like that. That's to be preferred in science. So, again, it doesn't mean it's true, but there's certain things in science like parsimony. You want to have more physical theories, less occultic practices that would be preferred in science. Okay. So does everybody get that? If there's an explosion here, you have to change your language within Einstein relativity. From reference point sun, it's happening now. Why? Because that's the light. Then it's going to take 8 minutes for that light to hit the Earth. What's that? For reality on the sun to occur in your perspective, in your reference frame on Earth, it will take 8 minutes. Not just you perceiving, it won't actually even happen. So this is going to get into the possibility of time travel. If reality is determined and constrained by the speed of light, if you could go faster than the speed of light, if that atomic bomb was going off on a planet if you could get faster than the speed of light, you go to the future and stop it before it happens. Isn't that interesting? Okay, I want to share another experiment that we did with Newtonian optics that might... Events occur and exist within light. Do you know what a camera obscura is? You can make them when you have a solar eclipse and you get your little shoebox. Okay. So Newton does this experiment where he uses like a room as a camera obscura. So imagine it's daytime, and we tape up, and we did this actually in our senior Newtonian optics class. We taped up every single window, so no light. It was absolutely dark. Then we put a pinprick in one of the sheets. So now a little stream of light came through. You could see it coming through. Then we took, just like this projector, we're doing the same thing. There is an image. Where is the image? You think it's on the projector. It's not just on, it's in every It's in a continuum. From that projector, the source of the light, to here, where it's cut off. How do I know that? Because the medium is transparent and you can't see it, you need to take something that's not transparent and slice the transparent. Look at. That means that image is in every aspect of reality. Again, there is no reality beyond the light. So the future really doesn't exist. Why? From the point where light has not hit yet, there is nothing there, because the light determines what is real. And I thought, well, that's just the image, right? That's like a still image. And by the way, how close you get is called the focal point. And it's going to be upside down, because, yeah, you have an apple like this, the light, that apple will like this. There's the focal point, and then, okay, so this line on the bottom will become the line on the top, and the line on the top will become the line on the bottom, and therefore the image will be reversed. You have to switch it on electronics, or your brain actually flips the image that's on the back of your eyeball. Pretty cool. Okay, it gets even cooler. So we did this experiment where the outside image gets put on here, but it wasn't an image. It was live, and it was upside down. There were like people walking upside down and birds flying. I was like, are you kidding me? And at that moment, my mind was just blown, because I realized the reality is in a continuum contained within light. Now go read the Prelude to John. And he was the light of men. And the light came into darkness, and the darkness comprehended it not. That's why I said there's actually theological implications. And this is going to evolve into a theological conversation very soon. But here's the problem. Theoretically, since that's blowing up, and that's a different point in time than you are, and that reality is going to take 8 minutes to get there. Again, if you could go faster than the speed of light gets to you, you could actually get to the sun before it blows up and stop it. You can time travel. What's the problem? You can't go, nothing can go faster than what? Speed of light. So physicists thought, well, you know what? There might be a way to cheat that. What happens if I have a large enough mass? It's going to bend space-time even more. Could it bend it enough that it brings 2 points of space together? Theoretically? If it brings 2 points in space together, guess what it does? It brings, because every point in space is a point in what? Different point in time. You could bring 2 points of time together. So if you walked through that, you could time travel. Now, is that possible? Well, they've theorized that if you have a large enough sun that becomes a red giant, explodes into a supernova, the imprint will still be there, left over, i.e., gravity. Gravity could be so strong from that theoretically it could bring 2 space-point times together. That if you went through, you could actually travel into a different time. But the problem with that is, guess what really strong gravity tends to do? Yeah, have you seen the one where they drop the camera into Jupiter? And they're trying to figure out, is there a solid core or is it just gas all the way down? and it's just kind of going through like clouds and stuff like that, and then eventually it's like it just crushes and goes out. Why? Because the gravity gets, well, that gravity is nothing compared to what a black hole, a large enough black hole to bring 2 space point times. So what do you think is going to happen to you if you walk through those? By the way, it's called a wormhole. Almost said wormwood. It's called wormwood.
So is a black hole something that was mass, that had more mass added to it, to where it was so heavy that it's still there, it's still circular, but it's so heavy that light can't travel from it?
So it's not that mass is added, it's already mass within the space-time fabric.
So you're saying that black hole was always a black hole?
No, for example, if you look at, pretend that that's, we'll just go to this one.
I mean, it could be like,
There's no black hole there because if I'm looking from Earth here, I'm seeing a sun. There's nothing black there. It's actually shiny. If that sun explodes, there's obviously, I'm just looking in blackness, okay? Well, why is it called a hole? Well, because from the gravity left over, the imprint from the leftover of how much mass that had, there's still bending space-time fabric. Now, how do you detect black on black? Well, that's hard because you can't see it. Well, notice if the space-time fabric is curved, light either will be sucked into or curved around the... Actually, did you know that we just got our first image of a black hole?
but could you not get a mass that's so large and another that made it so large that it triggered the event where it still exists, but now it's so heavy that light can't travel past it?
Light can't travel past it.
Right, but I'm saying, could you have something at one point and then another point where more mass was added to it? That
I don't-
it would become,
No, I don't think that's possible. Because everything will be destroyed that goes into and be shot out on the other side of the universe somewhere, wherever the 2 points are brought together. So you couldn't add anything more to... Yes, sir. To tear? What's kind of what I guess a wormhole is. It's kind of a tear in the fabric or a warping. Yeah. By the way, a good, or the curvature of the best way to think about it's not really a tear, it's a curvature that could bring 2 points together, or multiple points. In fact, there's something called that the shape of the universe, there could be certain points in which line up that everything from our perspectives of past, present, and future would all converge at one point, called the event horizon. So everything that has happened, that's happening, and from your perspective, what would happen within the bounds of light would all converge on one single point in space. That would be the event horizon. Probably where, like, when you die, you have to walk through the, right, into eternity or something. I'm joking. I don't know, but don't quote me on that. But obviously, if that does that to a camera, you going through is just going to obliterate you. A good movie, by the way, that kind of gives, I think, this is very hard to visually represent, is Matthew McConaughey in Interstellar. Is a great, this is where you see, so remember, he lands on that planet that's next to a black hole, and they make a mistake, like a 5-minute mistake, something like that. What happens to the person on the spacecraft? It's years. He's like 10 years older or something like, or like however. And then it's even worse back home on Earth. It's like my daughter is completely grown up now. And they're like, I always understood Einstein's relativity theoretically, but now it's really hitting home. Now, what general relativity is rather than thinking about particular cases, it's just generally what you have in terms of gravity, that space-time being bent or warped by larger mass objects. Again, because once that's warped, it's going to take light longer to. Therefore, each object, given its mass, will also affect space and time. So if we could set up a Skype, and I send you to a large massed object, and we're on Earth, what we will see from Earth is, but you're all slow, right? And you'd see us being like, they're super fast, okay? So that's both special relativity and general relativity. Questions? You just did Einstein. Can you believe it? Well, it's interesting that that means if, again, so with him, space and time are something out there, the space-time fabric, okay? But in sense of like Kantian, if it's psychological and we experience time differently, you've seen like a fly on like the Discovery Channel or something like that, National Geographic, and the guy's like trying to swat it, right? Like super fast. What does the fly perceive? Soul. It's like, it's experiencing time differently. Things are slower, so it can react to. So that might be a suggestion that, and obviously, maybe animals perceive time different because they have a different constitution. Let's go back to Aristotle real quick, and then we can go into the theological aspects of time. Aristotle has a nice definition of time, and he says, again, he's kind of a middle ground. So he says that time is psychological, but it's grounded in something physical extramental motion. And what he says is time is the number or numbering of motion with respect to before and afters. Okay, so let's take two things in motion, ball A and ball B, and number the magnitude. So that for every unit, let's see, for every 10 units, B will travel 1 unit. Okay. Aristotle says when we take something in motion different from something else and understand, is that time? No. Is that time? That's like my nephew. No, that's the clocks, the motion of the clocks is telling time. Well, where is time? It's in between. It's the ratio, the relation between the two movements. That when you see that there's something between them, that's when we determine time. For example, number this magnitude right here. Take something else that's in motion here and number it. Okay? That is not time, and this isn't time. But when you take this, and I walk a given distance, or move a given distance, and compare that to another motion, in between those two is time. So you could say, Professor moved 10 feet in 2 seconds. And there you find time. That's a pretty cool definition of time, isn't it? I mean, there's some obviously problems with that. But what Aristotle seems to suggest is that time seems to be determined by the now. And the now is something like a point. Remember what Euclid said, a point doesn't have any part. Now, why am I saying that? because it's going to set up for something really cool with Augustine. The paradox of time. Assuming that time is determined by now. So what's actually real about time seems to be, or at least determined by what's going on now. And then we measure, what would be in the future and what are the past. But what really seems to determine it is what's going on now. That I'm moving now, this is my future, and that's my past. So Augustine asks, okay, you can have intervals of time, and you can say that those are either long or short. That time has duration. It went really fast, the day was really long. And he starts to analyze that and says, does that even make sense? Can we say that we are now in, I don't know, what's today? The 23rd of April or 24th? 23rd. Is that our now? Is that what exists? Well, what is a day made up of? 24 hours, of which, 21 or 21 and a half are gone. And 3.5 are not yet. So it's like, okay, you can't actually say that the day was long or short because the day doesn't exist. Well, can I say at least the hour is short or long or exists? Well, what is the hour composed of? 60 minutes, of which some are gone and some are not yet. So you can't even say that the hour is long. Well, what about minutes? Can't I say this minute is either short or long, or this minute exists right now? Well, what is a minute composed of? Seconds. So on, ad infinitum, because you can keep breaking this down. Well, it starts to seem, well, what does actually even exist? He says, the now. Well, what's the now if it's not any extension? Something like a point, a mathematical point. So that means the future doesn't exist and the past doesn't exist. The only thing that exists is the now. And your now has no extension. He says it's ever fleeting as contrasted to God's now, which is ever present. Like the fullness. Now you can imagine, how do you, if time is just simply a stringing together of different points, how do I experience anything intelligibly at all? If there's no extension, right? If my reality is ever fleeting, that goes back to Heraclitus. You can't step in the same river twice. Try to name right now. It's gone. Right now, it's gone. So how do I apprehend or have anything intelligible? Augustine's solution is the distentio animi or distentio mentis, to distend the soul, to stretch out your mind as if it did have extension. Because the only thing that you can perceive as an ever-fleeting now, which is the closest thing to nothingness without going into non-existence. Whereas God's now is ever-present, which is the fullness of being. And therefore, what you have to do, the you that perceives, has to stretch out your mind as if it were extended. And then you can now perceive of the now as if these categories actually existed in reality. Past. There's the present, which is the only thing that really exists. in the future. Once you make these constructed mental categories, you stretch it out, you have a context now to perceive of the now flowing through your mental perception of future and past. But they don't really exist. It's you have to create and stretch out your mind so you can perceive which is practically imperceivable. What's amazing about that is that Augustine anticipates Husserl's phenomenology by 1,600 years. Husserl is something very similar. I hit middle C. Boom. Okay. I'm not sure if that's middle C or not. But this is E, I think. So let's say you hit E. Okay. Now, because time is simply a series of different unconnected nows, because they're not extended. They have no extension. If you just had a bunch of nows that are like points, it'd be like having Alzheimer's, right? You'd be surprised by every next successive now. Like you have new friends, new sounds. You're like, whoa, didn't see that one. Wow, that's... But you're not. You know that when you hit C or E, that's the same C that you experienced in the past. And then when it proceeds into what you would call the future, you're not surprised. And what Husserl says is because, in a sense, the present is stretched out. It's got one foot hanging off into the past, so there's a continuity. You know, oh, that's the same C or E that I heard before. And then stretching forward into the future. Augustine already nailed that. Isn't that amazing? Okay, that sets up well, what about God? Typically, issues of time present particular problems. Typically, people think of God as existing outside of time. Well, what does that mean? It's almost like, okay, now this isn't any Illuminati all-seeing eye, but traditionally, by the way, the occult uses Christian symbols and gives them new meanings and stuff like that. So, but traditionally conceived, the all-seeing eye represents what? Omniscience. See everything. So God, if you conceive of him being outside of time, because he creates space and time, really what he sees is life reeled out almost like a movie reel. Why does he know things and all things? Because he's outside of time and he can see what you consider as past, present, and future. Well, I remember being younger and thinking, well, that's interesting because how does that relate to human freedom then? If God always foreknows the future, that this guy's going to jump into this puddle, does this person have a choice? God's outside of time. He already knows it. If you're like, oh, I trick you and jump into, you either destroy God's foreknowledge or you simply just change the conversation and say, he already knew, it was already written out. Right? Why? Because he's outside of time. From your perspective, you actually think, well, that's problematic for people, isn't it? Most people want to keep their human freedom. But at the same time, they don't want to give up God's sovereignty, at least theologically speaking. Okay, there is a famous, it's called Clarence and the Omelette, to really appreciate this paradox and problem. I'm going to read you an argument called Clarence and the Omelette. Now, Clarence is an omelette addict. He loves them. And the question is, does Clarence have free will to choose whether he's going to eat an omelet or tomorrow or not? So, premise one. It is now true that Clarence will have a cheese omelet tomorrow for breakfast. Okay, now you can change that. you can say it's false. He's going to choose not to. The argument will still run the same way. It will still end up being the same conclusion. For the sake of the argument, we'll just assume that he's going to choose to eat. So that's a fact. It's true. Number 2, it's impossible that God should at any time, believe what is false or fail to believe that anything's true. It's called the premise of divine omniscience. If he could fail in knowing things, he's not omniscient. He doesn't know all things. 3, and this follows from premise 1 and 2, God has always believed that Clarence will have a cheese omelet tomorrow. That follows from premise 1 and 2. Or if you change premise 1, he's always believed that he won't. If God is, number 4, always believed a certain thing, it's not in anyone's power to bring it about that God has not always believed that thing. Inalterability of the past. 5, therefore, it's not in Clarence's power to bring it about that God has not always believed that he would have a cheese omelet for breakfast. From premise 3 and 4, that follows. 6, it's not possible for it to be both true that God has always believed Clarence to eat a cheese omelet tomorrow, and that in fact Clarence does not. Therefore, it's not in Clarence's power to refrain from having a cheese omelet for breakfast tomorrow, so Clarence eating a cheese omelet tomorrow is not an act of free choice. And therefore, there is no free will. La-da! Happy? I got a way out of this, though. There's 2 different typical ways that you can err in argumentation, either in the argument itself, which there was no errors in. There were no logical errors or non sequiturs. The other place that you can err is your starting point. For example, one might argue, Kant, your arguments are impeccable and infallible, but I don't agree with you. One way that you could go about it is, I don't agree with your starting point, your assumption, that there are no essences, that the world is simply just a sense manifold. Okay, well, what was the starting point here that we assumed? Yeah. I don't know if that's correct. And typically, we have a fallacy of ambiguity. What do you mean by time? In the Greek New Testament, there's 2 different words for time. Does anybody know? Chronos, chronological time, and kairos. Now, so chronos is like clock time, chronological time. It's quantitative, chronological, and it's measurable time. Kairos, on the other hand, is qualitative. It's a qualitative moment in time process. Sometimes it's often translated as right timing in the Greek New Testament. The appointed time in God's purpose. Let me give you an example of this. So suppose that you tell a funny joke, and I'm like, great timing. Is that because you told it at 9:30? Is that why it's so funny? Ha ha ha. Well, what do we mean when somebody has good timing? Yeah, it's almost something like everything was just right. It's like all the events and the people, everything was set up such that the quality was, when you came in with that line, it just made perfect sense and it was hilarious. It had nothing to do with chronology. That's kind of a notion of kairotic time. And in terms of Christian theology, it's a time in which God believes is the right time. It is when God acts. So when you look at the Greek New Testament, the Septuagint, you never find chronos applied to God. It's always kairotic, right timing. And specifically within the New Testament, it's when God sends his Son at the right time. It talks about in the fullness of time, and the word's kairos, God comes into the world. Okay, sort of suggest not because he came at the particular calendar time, like good timing. No, it was like everything was just right. And to get an appreciation of this, Augustine's City of God talks about, and it's really nice. You might hear these atheists say that, well, Christianity, nothing new, just borrowed from pagan religions, right? There's various arguments that you can give to refute those folios. But here's one of them, that Augustine reverts that and goes, God, there's a verse from Genesis, what men intended for evil, God intends for good. He will take the bad things that you do and make something better out of it. Remember when we talked about theodicy, that the problem of evil, one way out of that is that God brings about something greater. And so God will work with synergistically every person's actions. You do something, whether it's good or bad, God matches it and does something and pulls something even better. Ultimately, he brings life out of death. And what Augustine shows in the City of God is he goes through all the Latin and Greek poets and philosophers. He tells the whole story, and he shows that through men's actions, that God is countering that and preparing the soil of history so that when God incarnates himself and comes into the world, it's right timing. At the fullness of time, he comes in so that world history now understands what the significance of this means. And he goes through like Clytemnestra, right? The notions of sacrifice and the poets and stuff like that is, look, God is even using the pagans to bring about Christianity. That reverses the argument on if anybody ever at pagan says, oh, Christianity is just a bunch of, borrowing from, God used your pagan religion, despite its stupidity, to bring about the truth of Christianity. It's not borrowing, God's using it to prepare the soil of. So that's really interesting perspective. Now, another interesting perspective is in terms of the grammar and philosophy of chronology. Obviously, it doesn't make any sense to say, I'm here in the class right now, but I'm also here at the past and the future at the same time. That's because in chronological, one after another, past, present, and future are distinct. They're separate. They can't coexist at the same time. Guess what? Kairos. They can exist. In fact, past, present, and future always exist at the same time in Kairos because it's not quantitative, it's qualitative. And so what God's perspective is not outside of time. He is, and again, this is really interesting, because Martin Heidegger's Being and Time, his conclusion is being is time. And if you can distinguish two different types of time, chronos and kairos, then that means there's two different ways of being. So you could take this and say, God doesn't exist outside of time. That's a fallacy of ambiguity. You need to qualify in what sense time. He's kairotic. If it's kairotic and Martin Heidegger's correct, being and time are equivalent, then his being is fundamentally different than yours. Well, what is his being? According to Augustine, your being's ever fleeting. It's the closest thing to nothingness without going into non-existence. What is God? Well, in the Western tradition, the great I am, the being. And we talked about orthodoxy, that God is beyond actually even being. But it still holds he is the fullness of reality. He is the grounds of reality. He is an ever-present. So what that means is that God is present with you if you have this assumption that he's not outside of time. He is time. He is kairotic time, and he's the fullness of being, the grounds of being. then why does he know or foreknow things? Well, in one sense, it's improper. You're mixing categories, right? It's like saying blue smells faster than Wednesday. It's like you're either having a stroke or you're mixing categories. If you say God foreknew in the past, what are you doing? You're mixing categories. You're mixing chronological categories with kairotic categories. They don't belong. These are anthropomorphizations that should not be applied to God. We might use that in a loose way, but when you get to philosophical problems, theological problems like that, it better sort it out and make the sort of distinctions like this. So now we can say the reason why God knows is because he's present there with you. Not outside of time. He is in the now, but he is in a very different way. He's in the fullness, whereas your reality is ever fleeting. Therefore, he sees things from a higher perspective, the highest perspective. Let me give you an analogy. Suppose you're on a building and you're looking down. You have a higher perspective, and there's a lady walking, and she can't see from her perspective that there's a car coming that's going to hit her. From your perspective, you see her future. Her future is she's going to be hit by this car. Do you know her future because you exist outside of time? And does your knowledge of her future determine her? No, she has free will. But she has a lower perspective. She can't see everything. And Boethius talks this way, that God simply, everything's present before it. What you would call past, present, and future, everything's just present before God. What you would call that past, I call it present. I'm present, but I'm always here, is his from the highest perspective. So he can see things and knows all things because he's present with you in a kairotic way. That actually preserves God's sovereignty and human freedom. There's a synergy there. They're not mutually exclusive. So you can make a distinction on. So that's a potential way out of that. What do you guys think? You like that? Okay. Let me talk a little bit about, from my own faith perspective too, and the notion of kairos. And then we'll end. Martin Heidegger is judging you, saying being is equivalent to time. And if you think the opposite, I'm judging you. This is called the icon of the sign. In Orthodoxy, we use icons. It's called theology and images. And it's an essential part of Eastern Orthodoxy. And I'll explain the significance and how this relates to that. Okay, so the idea of kairos. Now, it's really interesting because as clergy, the first thing that I say in the liturgy after I do the kind of, I put on my vestments and I do the prayers that go back to like the ancient Hebrews, right? The priestly prayers of putting on vestments and stuff like that. And then the main priest will do prayers before the altar. And after he says a certain prayers, I turn to him and I say, it's time for the Lord to act. Now, that doesn't mean that it's like, Father, it's 10 o'clock. It's time for the Lord to get the liturgy on. It's not chronological. The word's kairos. And what we believe is that at that point, the kingdom of heaven and eternity breaks into the temporal world. And you now experience mystically and invisibly the way God experiences time and reality. Past, present, and future are all present. This is often depicted in iconography. Iconography is called windows into heaven. And so from the Christian tradition, we obviously believe that when you die, that's not the end, that you live. And the righteous who become saints live with God awaiting the physical resurrection. It says in Revelation, Lord, Lord, how much longer before you avenge our blood? They're alive, right? And so they have an eternal perspective. The icons are a window representing a different type of world than this material, physical, three-dimensional world. That's why oftentimes they're depicted kind of two-dimensionally, kind of flat, to emphasize that the world of the kingdom of heaven is different than what you would call real. It's more real. Now, how do you emphasize that? Artistically, you make it you contrast it to what you would call realism, because that's not realism in art. It looks more like a cartoon two-dimensional. That's to emphasize the kingdom of heaven is different. Okay, furthermore, oftentimes in icons, what you will have is, because it's supposed to be depicting a window, that you look through a window. You don't look at a window. You use it to see what's on the other side. And what's on the other side is kairotic. It's the kingdom of heaven. And the kingdom of heaven, from God's perspective, and the saints, past, present, and future, are all one. And therefore, oftentimes in icons, you will see from what your perspective, like St. Paul, right? You'll have him persecuting the Christians. You'll have his conversion by Ananias baptizing him and laying hands on. And then him as St. Paul building the church and going, all depicted in one moment. That is a vision of Kairos. Now also, what's really interesting, to emphasize that the kingdom of heaven is outside of chronological time. Did you know the Sabbath, the Jewish Sabbath, is on the seventh day? Do you know what we call the liturgy? The eighth day. Why? Because it's out of the chronological calendar. The eighth day is outside of chronological time. So this is where the kingdom of heaven and eternity literally break in. At the words of, it's time for the Lord to act. And that will ultimately culminate in the consecration of the bread and wine into the body of Christ, and then everybody partakes physically of the reality of Kairos in the kingdom of, and now you're all in communion together. That's why they call it communion. Okay, so what's really nice about this image, and then we'll end with this. Who's this? Yeah, Mary, the Mother of God. And what's interesting, she's not eternal. She's a particular woman, created a particular time, chronologically, in a particular place. Yet, who does she give birth? And there's actually a name for, it's, I'm trying to remember the Greek, but it's translated containing what's larger than can be contained. So this represents her womb here. And what is she containing? She's containing the creator of the universe who's eternal. It says in John, in the beginning, was the Logos. And the Logos was with God. And guess what? The Logos was God. And everything that was created through the Logos. All these planets. So you see the whole cosmos represented behind the Logos. Nothing was made that was not made through the Logos. Even that planet Earth, at that particular time, in chronological time, with that particular woman, contains, right, what can't be contained. And therefore, what you have is, again, a notion of the liturgy. Incarnated. You have a breaking in of eternity in a chronological time. You have Kairos. You have eternity that can't be contained. Being contained in the womb, and there's this beautiful paradox of how is that? It's the mystery of the incarnation. Who could explain something like that? That all of this was created through, even the cause with this particular planet, this particular woman there, and yet she's containing and fleshing what was invisibly, could not be circumscribed. And so I think that's a nice visualization of the theology of the East. And you end with the notion of time, Christ the King, the Alpha and Omega, the beginning and end, in which all is present before, and in his right timing, picks the right woman to incarnate and to enflesh himself to become one of us, so that he may raise all of humanity into the kingdom of heaven and to become participators of the divine nature in as much as possible. Sound good? And we end our philosophy of time. So we did a wonderful kind of journey through philosophers, through the physicists, and the theology, and how that pertains to different things too. Questions? If not, I will see you next week.